Okay, here we want to look at ways to solve exponential equations. Exponential equations are simply equations that contain exponents. It's that simple. All right. So we're used to solving algebraic equations where we need to isolate x, but in this case we need to solve exponential equations where we find x. Now the first thing we want to look at, and I'm going to put this in red, our goal is to obtain the same base. Will we always be able to obtain the same base? No. But this is where we're going to start out, and we'll talk about that later. But our first goal is to see, can we obtain the same base? So here, we have 3 to the x is equal to 9 to the x plus 2. So we want to see, is there any way that we can write 3 and 9 with the same base? Yes. We're going to go 3 to the x, and 9 we're going to rewrite that as 3 squared. And then we're going to put that x plus 2. Okay. Once again, instead of 9, we wrote it as 3 squared. So now we have the same base. So now, since we have the same base, there's a rule that we learned earlier where if you have the same base, we can bring it down and look at our exponents. So that's 2 times x plus 2. It is imperative that you put the x plus 2 in parentheses so we can distribute it properly. It follows x is equal to 2x plus 4. Okay, and now what I'm going to do, I'm going to take this positive 4 and move it over to the left side and make it negative. Some people do it like this. But I'm going to take this positive x and move it to the other side. And 2x minus x is going to give us x. So our final answer should be x, negative 4 is equal to x. If you did it another way where x is equal to negative 4, that is perfectly fine. Okay, now let's move over to the right. 4 to the x minus 3 is equal to 64 to the x plus 4. Once again, we have 4 and a 64, and can we write these with the same base? Yes, we can. We're going to say 4 to the x minus 3, and 64 could be written as 4 cubed to the x plus 4. Let me make this a little clear. To the x plus 4. Okay, now since we have the same base, we move to the next step. We move to the exponents. Those are the rules in the book that you've already learned. X minus 3 is equal to 3x plus 12. And I'm going to do this and try to make it a little more clear for you. All right. We're going to move. We have to get our x's on one side and our numbers on one side of the equation. So I'm going to say x minus 3x equals 3 plus 12. Now, all I did in this case, I moved this 3x was positive, but on the other side it was negative. This negative 3, this was a negative 3, and I moved it to the other side of the equation and made it positive. That gives us a negative 2x is equal to 15. And when we divide both sides by negative 2, x is equal to negative 15 halves. All right. So now, that's how we do these types of problems with the same base. Now let's look down. We have 8 to the x plus 4 is 16 to the x plus 1. Now, can we write the same base here? Yes. But 16 cannot be written with a base of 8. 8 to the first power is 8. 8 to the second power is 64. So we have to find another base. What's the common base that we will use? Let's write 8 as 2 to the third power. And let's write 16 as 2 to the fourth power. Okay? Now we have 3x plus 4. 4x plus 1. Okay, this gives us 3x plus 12 is equal to 4x plus 4 after we distribute. Okay, now I'm going to do this. I'm going to get my x's on one side of the equation and my numbers on one side of the equation. I'm going to move my positive 4 to the left. And I'm going to move this positive 3x to the right and make it negative. Negative 4 plus 12 is 8. 4x minus 3x is 1x. You can go through the steps right here. And now on this very last problem, I want to do this. This is 1/25. But listen, we can still write this with a base of 5. Just remember our rules concerning the reciprocals. So this is 5 to the x minus 6. Remember, 5 to the second power was 25, but since it's 1 over 25, that's going to be 5 to the negative 2. Okay? We stick to the rules. We have the same base. X minus 6 is equal to negative 2 times x minus 2. X minus 6 is equal to negative 2x plus 4. Okay, and now let's do this one. I'm going to move this negative 2x to the left side. I'm going to move this negative 6 to the right side and make it positive. Okay, I have 3x is equal to 10. And once I divide both sides by 3, x is equal to 10 thirds. So remember, anytime we're solving exponential equations, our first goal is always to try to obtain the same base on both sides of the equation. We will not always be able to do this. Sometimes we will have to take the log of both sides, which we'll see down the road. But our first step is to always try to obtain the same base. And if we do that, we'll turn our problem, we'll just make it a lot easier and simple for us.